Hey guys, we're going to go ahead and get started now. This is Brad from Motion Media. I just want to thank everybody for coming, and I'm sure that you will get a lot out of this webinar. There's some really cool new things in V-Ray 3.0 that I think you're really going to like. As far as questions go, if anybody has any questions, you can type them in to the question box, and if it's something that I can answer, I will. Otherwise, if you want Simon to answer the questions, please hold them to the end, and we'll try to get through as many of them as we can. And I guess with that, I'll just go ahead and pass it over to Simon and let him show you V-Ray 3.0.
Thanks. Hello, everyone. My name is Simeon, or Simon, and I'm a 3D artist at KS Group. Today I'm going to show you one of the most anticipated software releases this year, V-Ray 3. So, I'm going to show just a couple of new features that we've been working on, and there will be much more to come. First of all, before we start, I would like to show quickly our dedicated website for V-Ray 3, and there is a huge label stating that V-Ray 3.0 beta is now open, and for those of you who didn't realize or who missed the news, yeah, the beta is open. You can go ahead and join the beta by clicking this button here, and you can download V-Ray 3.0, test it for yourself, and see the features that I'm going to show you now. Just a couple of words about the beta. It's going to be on a couple of phases. So this is the first phase. The first phase has been opened right now, but we are going to release, actually not phases but stages. We're going to release a couple more stages and improve the features, introduce more features, new fixes, and so on. So stay tuned. You can check out some of the new features by clicking on these icons on these thumbnails down below, or clicking the features list, and you can check out some of the awesome new stuff that we're going to provide. I'm just going to open up the one scene here. So here's 3ds Max. First of all, I'm just going to say a couple of words. Probably most of you are, I don't know, fans of V-Ray, I guess, since you're here. Probably most of you like using V-Ray or are interested in using it. As you well know, V-Ray is a renderer, so it provides rendering, shading, and lighting tools for the artists. Great, I can see that some answers. So what we try to do is give you more control and easier control over how you can shade your scenes. In V-Ray 2.0, we introduced radical new engine of rendering, which was called V-Ray RT, and it was like a preview render, which gives the same result as the production render. This way, this is just one of the features that we introduced back there. Now we'll try to do even more with V-Ray 3.0. The first new feature that we can that I've prepared to show you is actually some speed improvement thing, and this is called the Embry helper. Not a helper, but the Embry functionality. And as I'm showing the interface, you can see probably you can see that there are some changes going on in the interface. First of all, we can see this button here that says Basic, or here it's everywhere in all the menus, and you can see that if we press it, it goes to Advanced and then to Expert. So what we have done here is we went ahead and hit some of the parameters that a common user, everyday user, wouldn't touch on an everyday basis. This way, we shrunk down the interface to something much more nicer and yeah, neat and tidy interface. And the options are there. So if you want some more advanced control, you can just click. I'm having an autosave here. Okay, I just interrupted that. You can go to Advanced or Expert or even Expert, and you have all the controls that were there. Same goes for each and every tab here. So if you would like more advanced control, you can just switch between Basic, Advanced, and Expert everywhere. So this way you can see that we're thinking about improving the interface, improving the workflow, getting rid of the things that you don't need to get in your way, to obstruct your workflow, and basically speed up your work and loop development process. So here, the first feature that back on the topic is the Embry functionality, and probably some of you know that recent Intel processors has this set of instructions that allows to compute ray tracing operations much faster, doing something internally. I'm not exactly sure if I have to explain the process in depth. You can go ahead and search online if you're into this kind of if you're interested in these things. However, we have given the possibility to make use of this feature, and if you have a recent processor which supports SSE instructions and AVX, the AVX set of instructions, again you can read about these if you search online. You will be able to make use of the Embry functionality. And to test this, probably we can just start a render. Here is my render. And let's just make a render without Embry. This is scene that uses brute force for GI. So we are reviewing so we are using only ray tracing in its purest form. I would like to show the difference that using the use of Embry gives when in production setting. Let me just enable my history. And yeah, it's on my other screen. Okay, so as we render, you can see another, yet another feature of V-Ray that we have introduced, and this is called something. This thing is called dynamic splitting. It's found over here in the settings, and it splits dynamically the bucket as you render, in order to make use of all your threads while rendering. So probably some of you know the problem with when some of the buckets hits a very glossy spot, and there are lots of subdivisions to get calculated, and all the other buckets are finished, and you have to wait just for one bucket. Well, this problem is no more. We have the dynamic splitting, and you will always get the most of your machine. So let's save this one, and I have made a couple of tests before. So let's see, this is 1 minute and 25 seconds if without the use of MV. Just one addition to this thing. Oh, where's my history buffer? Here I have prepared a rendering that I did with V-Ray 2.4. So this was the older version of V-Ray, and it took 1 minute and 32 seconds. So so as opposed to 1 minute and 25 seconds, there is some improvement, and this is improvement especially in the brute force engine. So this is another improvement that we were trying to that we were implementing, faster brute force calculation. I wanted to show you that since I'm making a webinar and my computer is a little bit overloaded for encoding and sending the picture to you guys, without the GoToMeeting running, we go to webinar. The render took 1.15 seconds instead of 1 minute and 25 seconds. So just bear in mind that the improvement is from 1 minute 32 seconds to 1 minute and 15 seconds. And this is only the internal optimizations in the brute force. Now, let's use the MV and re-render the image. And let's see how long does it take with the GoToWebinar running. Without the GoToWebinar, it took me 51 seconds. So, as you can see, this is quite an improvement. And again, we can see the dynamic splitting going into effect. This way I make sure that all my threads are utilized. So 58 seconds as opposed to 51 seconds without GoToWebinar running. Either way, we get around 37 seconds improvement in the speed, in the rendering speed, which is really cool. One thing though, this is very scene dependent, so the MV will make faster scenes where there is lots of ray tracing, a lot of brute force, so you can expect more speed improvement there, as opposed to other scenarios. Here is another example that I did. So this is V-Ray 2.4, as you can see, and this is completely closed space with using only brute force as well. So it took 2 minutes and 25 seconds for this render, and this is V-Ray 3. This is V-Ray 3, and it took 1 minute and 5 seconds. And we can compare. There is a little bit of difference in the noise distribution, and this is because there is because of these internal optimizations that we did. But for the similar amount of noise, we are more than twice faster. So pretty nice, and you can render these interior scenes faster now. I hope you like this. We'll move on to the next feature that I wanted to show you, and it's a small feature called maximum ray intensity. Let's quickly render, and again move the window over here. So when when we have a scenario where there is a bright light source and a glossy material, there is often this problem. I have seen it called the fireflies effect, or some other words I don't remember, but the firefly was more the most interesting to me. Was that you get very, very bright, over bright pixels like this one, or I don't know, these one here and this one here. So I have seen this people not being capable to cope with this problem easy. This one here, and this is because when we have glossy refraction or glossy reflections, some of the rays hit the environment, but which has smaller values or regular values, and some of the rays from the subdivision rays of the glossy rays hit this very bright light source. And since the very bright light source is I don't know, say 10 or 20 times brighter than the intensity of the environment, just one of these rays gives us a spike which results in an overbright pixel. So the way to fix this was either to increase the anti-aliasing, or I don't know, to fix your lights, but this will change the way the scene looks like. So it was kind of a hard task to deal with. So what we came up with is just one-click solution, and this is found in the global switches. But under advanced, we have maximum ray intensity, and if I enable this, and for the purpose of this demonstration, I have set it to 8. Now we will render, and you can see we immediately get rid of these overbright pixels. As you can see, it's just one-click solution. If what this does actually is when calculating the glossy rays, or actually light rays, V-ray checks against this threshold here, and if the intensity of each ray is higher than this threshold here, it's clamped or clipped to the value that we specify here. And because this value of 8 is large enough to give us high dynamic range result, we do not compromise our lighting, so the light setup doesn't change at all, but we just fix the overbright pixels. There is a question that I can answer now, since it's not that complex. Does this feature help to reduce the flicker in GI with GI in animations? Because this thing is responsive for glossy effects, such as blurry reflections and refractions. You either have to have lots of reflections in the scene in order to make use of it heavily, or it will help if you're using brute force, since brute force is using secondary rays, and it will be calculated. If you have a very bright light source that is generating these flickers, and you're using brute force, then yes, this feature will help you in dealing with this flicker. However, since okay, it depends from scene to scene on the specific scene. All right, and let's see another example. And in this example, I'm just going to show it here on the car paint material, and because we have flakes in our shader which are glossy, and we have a bright source somewhere in the upper left part of the image. We can see that the reflection of this light source gives us this occasional bright pixels. And this is exactly the same situation. We have some glossiness, or in this case some flakes, and we have the overbright pixels, which are hard to deal with if it wasn't for this parameter, the maximum array intensity. One other way to fix this that comes to mind is to clump the image and to use subpixel mapping, which will clump our each sample that is shot from our anti-aliasing engine. However, this will strip our high dynamic range image, and we will not be able to make any compositing after using this approach. With the maximum ray intensity, however, you still preserve the high dynamic range, and this is the very important thing and the very important difference. So in this case, I will keep the maximum ray intensity at 10. So each light in my scene will be limited at 10, which is pretty good for high dynamic range compositing. And let's take a look at the fireflies, and they're gone. So again, as you can see, we tried to deliver a simple and easy to use solution. So you just click one checkbox and decide what threshold to be used. Generally a value of, I don't know, 10 to 20 is, the default is 20 by the way. There is a question if the maximum ray intensity is affected by the color mapping, and no, it is not affected. The information is collected from the render, and the mapping will be done after this. So we are limiting the ray intensity of each light while it bounces around the scene, while it reflects and refracts, and so on and so forth. So this is an ongoing clumping, or I don't know, limiting, let's say. Because to be honest, for example, if we have a sun and sky system in the scene, and some of our glossy rays hits the sun, it will be like, I don't know, intensity of 10,000 or even more, and you don't need this intensity. It's actually really so high that you will never use it in any case, either ray compositing or anything else. But you will have to sample more. This is why we decided that the maximum ray intensity will be a good solution for situations like this. Okay, so let's move to the next feature. I hope you like this feature because it will just give you very nice renderings without any complex scenarios to fix this firefly things. I will show in this scene. I will show two features at once, and the first one is the progressive image sampler. We have introduced one more image sampler, and just bear in mind that this is not a separate rendering engine such as the RT, but this is just an image sampler. The good thing about this is that you can use any GI solution that you feel comfortable with, and then start using the progressive image sampling. And this is what is going to happen right now. So first of all, just a second, we are preparing the scene. First of all, our light cache is being created, and then we are starting to render using the progressive image sampler. This is different from the RT because first of all, it's a production render, so it's not interactive. You can't change anything in the scene while using this. However, it will quickly show you representation of your scene in just a matter of seconds, and then if you leave it rendering, it will continuously refine the image and get you a much better quality. So much like an unbiased render. So if you feel more comfortable using this approach, you can just switch to this progressive render and still keep, as I said, the GI methods that you feel most comfortable with. The second feature that I'm showing here is the hair rendering. As you can see, I have left one thing. The render stopped since I have set it to render for 1 minute. We can, however, set another time limit, and if we were rendering animation, as soon as we hit this limit, VRA will save the image and move on to rendering the next frame. On the other hand, if we set it to 0, this will render in unlimited amount of time. So, for example, if you want the best quality for this image for the time that you have, you can just leave it rendering, and when you come back from your lunch break, for example, you will get the best quality that you can. Without the great thing here is that you don't need to think about here, for example, you don't need to think about minimum and maximum subdivisions or color thresholds or subdivisions in lights and materials. Anything, all of these settings are just ignored because they will be continuously improved when using the progressive sampler, image sampler. So, yes, a very good feature according to me. Very good for testing and quick look development. And as you can see, we are rendering thousands of polygons here, not millions of polygons, thousands of hairs, and we can still have a good render time. This is just 1 minute rendering. Let's take a look at another example. And involving more hair rather than fur. So I'm just going to go ahead and render. And again, the window is here. As you can see, by utilizing one of my favorite VRA options or features of the VRA frame buffer, the follow mouse cursor, I'm just quickly rendering only where I want to render first. So you can see we have beautiful backscatter over here. So translucency of the hair shader, it's the same hair shader that ships with that's shipped with VRA 2.4. However, we have made a couple of improvements. The settings are the interface and the settings are mostly the same. However, we have taken care to improve the rendering speed and do not compromise the quality. So that's about it. Let's move on and take a look again at the progressive shader, and probably let me try and take a look at the car again. and wanted to show you one feature that actually in production. Okay, so if we render, this is a nice and clean render, and as you can see, we get a better and better result as the time goes by. I will go ahead and cancel this and show you the feature that comes with the progressive image sampler, which is called noise threshold. And in order to show you this, I'm going to set it to, I don't know, something like 0.05, and click check this checkbox, which is show adaptive mask. This, as I start to render, this mask actually will show me the pixels in just a couple of seconds, the pixels that are still being rendered, so in red. All the other pixels have reached the value of the noise threshold of this value here, over here, and will not be sampled anymore. So we leave more processing power for these red pixels over here. And as you can see, the red pixels are continuously dropping out or disappearing. And this is because we're refining our anti-aliasing here, and we're reaching this noise threshold. So eventually, in a couple of seconds, we will reach this noise threshold quality, and the render will be done. So here, actually, we have two conditions in order to stop the rendering, and the first one being the render time, the second one being the noise threshold. Whichever comes first, the render is considered done. However, using the show adaptive mask, we can see where our subdivisions, or where our samples are going, and where we need more anti-aliasing in order to get better quality. So watch what happens if I decrease this one and re-render again. Much more of our samples much more of our pixels are staying red and for a longer time. So that means we need more sampling in order to get to a lower noise threshold value, which obviously makes sense. As you can see, we slowly improve the quality here, and the noise, of course, will be much better. Or actually, the quality will be much better here. And naturally, along the edges, we will have this more sampling because of the anti-aliasing nature. So I'm going to stop this, and as you can see, this is a very, very nice tool for you to see where an anti-aliasing, where more samples are needed, where would be your noise, and very good debugging tool for your optimizations. I would like to add one render element in order to show you the various sampler rate is a render element that will allow us to see how many samples are processed. However, using the progressive renderer, we will not be able to see anything, and this is because this the various sampler rate needs some mapping, which is the lowest value of the sampling and which is the highest value of the sampling. And in the case of the progressive render, we are shooting samples constantly, so it doesn't make sense. So in order to demonstrate the sampler info, I have to switch to one of the adaptive methods. And when I render it, and if I take a look at the sampler rate, we can see from blue to red heat map, if you will, of the samples, of the value of the samples spent for each pixel. So here is the minimum amount of samples, and the red is the maximum amount of samples. Anywhere between, anywhere in the green and the yellow range, we have some value in between. So let me cancel this. And in our case, we have from 1 till 6. So this is the other way around. We can see where we need more samples, but after rendering the whole image, after finishing with the bucket, while using the progressive sampler and the show adaptive mask, we can see where our images, our pixels need more anti-aliasing, and where we have reached the desired level of noise. So it's kind of reverse debugging approach. And by debugging, I mean loop development debugging, or improving the quality. I will answer this question at the end of the presentation. I hope this is okay with you. Let's move on and show just another, yet another example of when this, when the progressive render is really useful. I'm just going to start with the rendering right away. And in this case, I have depth of field. So for effects like this that are usually they're rendered slow, they take more time to render with good quality. Effects such as motion blur and volume fog. All of these effects are very good to test and set up using the progressive render. So as you can see, in just a matter of seconds, we already have a very nice representation of what our scene will look like, even though we have depth of field. And as I said, motion blur and volume fog, this kind of effects are really good to set up using the progressive sampler. Let's take a look at some improvements in the V-Ray frame buffer. Again, this car. And I'm just going to render straight out of the scene. And here, while this is rendering, I'm just going to explain this feature. So we have some of you guys probably know this painfully well, the situation where a client comes and says, I really like what you have done, however, I would like to, can we just make a minor change in the color of this grid over here in the baggage compartment, and because I don't like this to be chrome, but I want it to be more of a brass goldish color. And most of you know that this will be a really painful task, because you have to render everything once again, and yeah, you will spend, the client thinks that this is just a minor change, but for the whole pipeline process, it's a huge thing. And this is where the next feature, which is called render mask, comes in hand. I'm just going to wait for the whole to be rendered so that we can see the whole thing. And I'm going to show you what the render mask is. The explanation would be we can just render selectively from our scene without re-rendering the whole image. And in this case, I'm going to say, let's minimize this, and say, I'm going to select this one, get my material, it's chrome, and in this case, I'm just going to introduce some coloration in the reflection. So, for the sake of, for the example, and now with my object still selected, I'm just going to say selected, render mask selected. And when I render, Just see how quickly the buckets render the rest of the image, and they just re-rendered my object with the new parameters. I mean, we have changed the color, but this is of course not only for the color. We can I don't know, plug in a map here. So let's put a checker in, dial it a couple of times more, and re-render. And now we have a tiled map applied on the reflection slot. And these reflections are again ray traced. They will see perfectly fine. So perfectly fine the rest of the scene. So you're not limited to re-rendering the whole picture, the whole scene. You're just re-rendering the object that you need. The other options include a texture. So we can plug in here a texture, and for example, if you are outputting a multi-matte element, for example, for some objects using the multi-matte system, and you had a render layer here which had some object masks, you can use this as a texture. You can use this. You can use as a texture here, or for the sake of experiment, we can plug in. Let's do it again with the checker and dial this thing a couple of times. Come on. Okay, there's something going on with my interface. Okay, cool. This is something I don't know what's going on, guys. You'll have to excuse me. Okay, let's create a new texture from here and plug it in. I'm not sure what's going on. Let me close this once again. Open it up. Well, we kind of fixed something, so I'm not sure why I can't select this texture anymore. Let me try and switch to the compact material and try if it works. Nope. Well, yeah, I'm sorry, I wouldn't be able to demonstrate it the way I wanted. So let's then assign something like a noise and re-render. Hopefully we can see. But yeah, you can guess that it will be applied in a screen space. Because I'm showing you the latest build, and it's still a beta, you can see that there are some things that we need to clean up and fix. So let's try it again with the checker. And let me change the color of this thing to, I don't know, blue, and re-render. Now you can see the checker is applied in screen space. So here we have the white part of the checker, and here as well. And wherever we have the white part, we are rendering with a changed color. And here, because the texture, the render mask is black, the render will not even bother to re-render this, and the black part is from our previous render. But now I hope you can see the effect. Of course, we have the option to set up include-exclude list. So which parts of the image are going to be, so you don't have to manually go ahead and select. and of course if you want to send this over the render farm, you wouldn't be able to select something before submitting it to the render nodes. So this is where include list comes in hand, or the other where we would be to select layers, the regular 3 Max layers. So that's about it. Let's open up the other the other scene, and here we have this nice Mercedes, and I'm using the progressive render here. Sorry, actually, let me start once again. If you notice this icon here, it's Open Lens Effect Settings. It opens it on the other screen. Here is the control. It says no channel, please re-render, and this is again because I have to restart the render. There is some minor issue going on. We will be fixing it before the final release. And now the error is gone. So what this gives us is a simple yet powerful lens effect post-process effect. As soon as I say stop render, and probably some of you might notice that we have the stop button over here, so you don't have to go and search for the cancel or pressing the escape button. You can use this one if you like. The lens effect gets applied in the image, and if I increase the weight, you can see now we have this beautiful glow, or bloom rather, and I can increase the size, play around with the settings, and they update real time. The good thing about this is that we have a couple of masks that are based from our scene, so based on intensity, object, and material IDs. And what's even better is that, let me decrease this effect a little bit, or probably at all. I can show the glare effect, which will give us, let me increase this one a little bit more. It will give us, can you see this rainbow effect? That's actually a banding caused by artifacts in our lens, which happens in the real world. And this is colorful because we have turned on the diffraction. If we disable that, it will be just banding without any coloration, and with it turned on, we have the coloration. The really great thing is that you can take it from the image, from the render camera, or from a specific camera parameters that you can specify over here. So if I increase my F number, I will be increasing the effect, which is natural, and if I decrease the F number, I will tighten the effect very close to the light source. So let's leave it to the default of fade, and you can change the blades if you want. So let's try it with 3, 4. Now you can see, sorry, let me try it with 4 and zoom out. Can you see let me increase the weight once more and the size a little bit. So you can see the direction like this. You can rotate it if you want. So yeah, it's pretty much like this. And by combining the two effects, you don't need to go into, say, composting software or Photoshop to touch up to get some glow going on. And this is the first convenience, and the second one is that you get to work with real camera parameters, and they will give you a proper and physically accurate result if you're using, of course, physical parameters here, or if you take it from the render camera. You can have the lens effect source, the raw image, as a separate render element. You can have the bloom and the glare separate, so without any combination. You can have them both if you want. And you have the mask that if you want to to go into compositing and do it yourself, you can have the bloom and the glare mask on a separate layers, which is really, really cool. So yet another hopefully time-saving improvement and feature. The next feature is the V-Ray VR matte material. And let's take a look. I'll try to run quickly through it. Actually, what a V-Ray VR matte is, it gives you the ability to transfer shaders from, say, 3 Studio Max into Maya or into Rhino or into SketchUp or any other platform that V-Ray supports, and the other way around. So now you can just quickly, for example, say, send the scene into Maya, Softimage. Both of these are supported by V-Ray, or so send it to Maya, and then you can convert all your shaders into V-Ray material. So in this case, I have created V-Ray shaders for each and every object here in my scene. And what I can do is go to Tools, V-Ray VR Matte Converter, and this brings me this toolbar, this pop-up window, which will allow me to work with. Let me just open up the material in my browser, and I can do something like this: new material library, save it somewhere, call it like temporary folder, temporary material library, or something like this, doesn't matter, and then drag and drop some of the materials into this then folder. So okay, these are enough. Then I can say use the current library or load the material from the hard drive, like this one for example, and then I can convert the library into V-Ray material, which will create separate V-Ray file, a V-Ray VR matte file for each of these shaders, or I can convert the whole library into one V-Ray material file, VR matte file. I have the option to pick and convert material, whichever I want, and I can convert the scene materials that are in use here, actually. This one, the scene materials, all of them will be converted automatically for me. And then later on, I can just go ahead and say, create new VR matte material, and then open up one of the files. Here I have a list of the shaders, and let's take a look at this. So I have Museum Base, or somewhere here I had all of them, so this one, and here I can have a list of shaders, and as soon as I select some of the shaders here, take a look, my material actually changes. So if I switch to another one, to this one, it will change, or to this one, it will change, and so on and so forth. So you can have lots of materials into one V-Ray VR matte. And the way to edit this is actually, we have a button here that's called Open Editor, and it takes a little bit to load. It pops up a new interface for editing the shaders, and this is a unified interface which looks the same in Max, in Maya, or Rhino, or all the other platforms that support the V-Ray material, the V-Ray VR matte. And here you can create new material like this, standard. Inside of it you can create emissive, reflection, diffuse, or V-Ray BRDF shaders or layers, and you can create all the shaders which you're familiar with. So you have diffuse, reflection, Fresnel, like this, lock it, unlock it if you want to the Fresnel, and all the common parameters that you're used to working with. Just the interface is a little bit different. So in this way, you can save the file, and open it up in Maya, for example. And in order to show you this, I'm just going to try and start up Maya. And meanwhile, I'm just going to open up the already created the scene with the VR matte materials. And here, as you can see, all of the shaders are VR matte. So here is Maya, and let's create a quick sphere. Open up my shading, my hypershade, and create VR material. Oops. And here I can navigate to, I don't know which one, say stones. I'm going to go ahead and copy this path and paste it over here. Okay, so I open it up and you can see we already have the same shader, and if I apply it and render, let's use the, oops, sorry, we have to switch to gray, and let's use the RT, and as you can see I have the shader rendered even in the RT. So I have to zoom out a little bit, zoom in a little bit, and since I'm not using color mapping, I see the color darker. However, if we fix this, 2.2, linear workflow, and let me just don't save the image and use the V-Ray frame buffer. Let's start it again, and now we have the correct turning off the sRGB. We have the correct image in our viewport, in our render. So you can see it's very easy to send scenes and to have a mixed pipeline utilizing the V-Ray VR matte, or it's much more easier than having to copy and paste all the shaders manually. Another new feature is the V-Ray metaballs, and here we just have a simple particle flow which scatters a couple of particles, and if I render I'm not going to have anything. So probably this is nothing impressive, but if I go to V-Ray to create V-Ray, here we have V-Ray metaball, and this will create metaball. This will give me the control to pick up positive particles, particles that will create geometry, and negative particles, particles that will subtract from the geometry. As soon as I pick up my particle source, I can have a use a preview, and if as soon as I increase my resolution and change my size to say 1, you can see that I have visualization in the viewport so that I can see how they will look like in the render. But if I turn it off and render, now we can see the metaballs rendered. And this gives us the ability to create very complex effects, such as this one. And it might take just a little bit of time, but bear with me. Because here I have created millions of particles, and they have to be meshed and rendered using the metaball, so it might take just a little bit of a couple of seconds. And there we go. So you can see by using appropriate shader, we can create this electronic microscope effect, which is pretty nice, at least according to me, of course. Okay, so I'm just going to move on. You can see, yeah, lots of details. All of this is meatballs. So I'm just going to try and wrap it up. And one really as a final thing is one really important thing to compositor, to the compositor guys. Again, I'm just going to show you that we can render this image. Actually, I'm sorry, I'm not going to show the rendering process, but I'm just going to show you the result, and this is, we actually can render, just a second, we can render deep images now using the OpenEXR 2.0, and let me just open up Nuke and show you the composition. That has been rendered here. The way to render deep image is from the frame buffer, here render to raw image, and then this is my render history. Here you have the checkbox which is EXR, and then you can say deep EXR, and by selecting the OpenEXR 2.0 the EXR extension, you will be rendering in a deep image format. And here is yes, and here is Nuke. So okay, so here is my rendered result, and here is the 3D map. As you can see, the deep image, which is displayed as a point cloud here. So this has been generated with V-Ray 3.0, and this gives me the ability to create complex effects such as color correction based on depth, and of course Z-depth, Z-defocus without edge artifacts, which is very anticipated and useful feature of the deep images. So I can change the focus and have a Z-defocus in post, and because it's a deep image, we have nice and artifact-free post Z-depth, Z-blur. So let me go ahead and close. And as a final thing, because I'm running out of time, really running out of time, as a final feature that I wanted to show you is render elements in RT, which I think you will like, because it will give you the ability to go into compositing even with the result coming from the RT. So as soon as I start rendering, I'll just wait just a few more seconds so that we can see a better quality image. And you can see we have all these render elements: alpha, lightning, reflection, global illumination. We even have multimates going on, Z-depth, specular, diffuse filter, and as a very good addition to this is that we support the light select elements. So we have isolated a couple of lights, and we can combine them in post and fine-tune or make changes to all these elements and get creative. So as we're rendering this, I'm just going to answer a couple of questions, because actually this was all that I have prepared for you today. So there is a question. Sorry, did we add the option of using Z-depth path rendering translucent and reflections? Not really sure if I understand the question correct, but we probably, okay, I'm going to stop the render and show what I think you mean. Is if we go here under reflection and refraction, we have the option to affect the color channel, the color and alpha, or all channels. So if you want to, for example, the motion blur or the motion vectors or the Z depth to be seen through transparent objects, you can set it to all channels. So when having this transparent object, the Z channel will be seen through this. Well, you mean translucent by using this effect, translucency. We have to test this, and I'm not sure if it's going to work because the translucency actually activates the glossy refraction, and you have to make an you have to be very careful when experimenting with this. If you have any questions, thank you guys. Thank you guys. If you have any questions, very specific, or you have scenes that are not working, you can always go to our forum and make a request there. Our support team is online all the time. They're watching the forums and try to answer as soon as we can. When is the expected release date for V-Ray 3? I'm sorry, I don't have the answer to this question. You should go to the website that I showed you earlier here and be on the lookout for news. So yeah, you can expect this. There was just one question that I couldn't answer. What is the relation between the noise threshold and the maximum subdivisions? Actually, the relation is if you decrease the noise threshold, and I think you're asking for the adaptive DMC image sampler. If you decrease the noise threshold, you will enable V-Ray to go higher in the subdivisions for more pixels in your image. So you will get better quality for the expense of render time. And if you increase the noise threshold, you will get faster rendering but more noisier picture. And here is another question, last I hope. Does the lens effect bloom glare still work behind glass? Yes, it's based on intensity of the pixels. So if they're bright enough and your glass is not that is not obstructing. I mean, if you have glass with fog color and the light is still bright behind this glass, you will get lens effects. However, you can limit this one by using Object ID as a mask. But if you want to test it, go ahead and download the beta. I encourage you to go and do this. There will be a couple of more betas as well with even more improved features and better features. So yeah, go ahead and do this. And this is from me. I hope you liked it. And if you have any other questions, you can submit them to, I hope you can submit them here or to Brad, and he will give a list to me, and I will try and answer them later on. So you guys can have all the answers that you need.
Yeah, that works. My email address for anybody that has any other questions is brad@motionmedia.com. So I can make sure and get those answered. Also, if you missed any part of this, it is recorded. It'll be up on our on our YouTube channel soon. So just look out for that. If you don't already follow us, you'll see it up there. And just want to thank Simon and Chaos Group for everything. It was a great presentation. I hope you guys liked it and learned something. And of course, who doesn't want to get V-Ray 3 now after this? But it's coming soon, so we'll see. And we'll see you guys soon. All right. Thanks for coming out.